Hello, and welcome to my talk about digital supply chain attacks, focus on exploitation of them. My name is Nethanel Gelernter. I'm CTO and founder of IONIX, formerly known as CyberPion, security researcher. I have a few talks at BlackHat and other places in the last few years. And since I founded IONIX more than 6 years ago, I dedicate most of my time to protect the modern attack surface of enterprises, an attack surface that includes the direct and indirect digital supply chain. My email is on the screen. Feel free to reach out. So talking about the modern attack surface, traditionally we had the data centers of the organization. With the move to the cloud, the attack surface, the number of organizational assets became larger. It is easier to create new applications, new services, and we care about many problems that can happen either in the on-prem or in the cloud. And it could be log4shell incidents, it could be more recent things such as MoveIt, and it could be misconfigured S3, BlackHat, or other types of misconfigurations. And the question is what we can do when these problems happen, not in our assets, but in the direct and indirect digital supply chain of our organization. We need to remember, every security issue we care about can also happen in our digital supply chain. And worse, the hackers don't care who owns an asset, but what they can gain by attacking these assets. Hackers love digital supply chain. First of all, they can attack once and hit many. By attacking a single infrastructure of a vendor, they can reach many infrastructures, many assets of organizations that are connected to that single infrastructure. Considering also the direct and indirect digital supply chain allows the hackers to consider more potential attack paths, and some of them might be less protected. Also, attacks that start via the digital supply chain are usually less easy to detect. So the attacks are more stealthy. On the hacker side, that's obviously an advantage. When we started handling digital supply chain attacks, it wasn't because that's an interesting theoretical threat, but because we met enterprises that get hit through their digital supply chain. And we heard about data breaches, although most of the cases think about this, they reached the news after 2017, but even before, there were issues that organizations handled that started from dependencies on external infrastructures. One of the cases that really changed our perspective was a ransomware event. An enterprise got a request to pay ransomware. The hackers added some pieces of information, sensitive ones, that they claimed they got from inside the organization, and that was basically a proof that they are inside the network and they can shut down critical systems for the organization. The incident response team did not find anything, and after an investigation, it was found that the ransomware threat was, the data was real, but it wasn't achieved from inside the network, but from an external mail system that the organization was connected to. So hackers do leverage digital supply chain to extort organizations. And we know about APT cases that started, that in which the initial penetration to the organization was done via digital supply chain. In the scope of this talk, the abuse of assets, infrastructures that are external to the organization. We will focus this talk on external assets, not on vendors. We are not gonna give grades to vendor corporation, but to focus on specific issues that can happen to api.vendor.com, to mail.vendor.com, to static.vendor.com. We will bring some Fortune 500 statistic, and we keep out of scope how the hackers take control of the external assets of the digital supply chain. And the reason is simple. the same techniques the hackers are using to attack organizational assets, they are using also to attack non-organizational assets, the digital supply chain. So when we talk about exploitation of digital supply chain vulnerabilities, the focus is the dependency, the relationship, the link between the organizational assets and the digital supply chain. So we can have an organizational assets loading code from external one. We can have organizational asset that is hosted externally. We can have mail servers that are external and used under organizational domains, and organizational domains are usually relying also on authoritative name servers or name servers that are external to the organization. Otherwise, they are not connected to the internet. And when there is a digital supply chain issue, when one of these external infrastructure is compromised or critically vulnerable, it doesn't matter whether it is due to log4shell, due to MoveIt, or due to misconfiguration in an S3 bucket or other cloud asset. What matters to the organization is how organizational assets are connected to the compromised or critically vulnerable asset. If the organizational asset is loading code, that's a MageCart threat. If that's a hosting dependency, that's asset hijacking. If that's a mail dependency, it is going to be mail hijacking. And if a name server is compromised, that's name server hijacking. In this talk, we will cover these 4 dependencies. The first one, the MageCart, we call it the most famous. The most common is the asset hijacking. Mail hijacking is the one we see an increase in exploitation or indication of exploitations, and name server hijacking is what we consider to be the most dangerous. Let's start with the first one, the MageCart, the most famous. So in a MageCart attack, hackers steal information by running malicious script in web applications. The name is after the MageCart infamous hacking group. Although there are solutions, again, famous problem, solutions were created against it, but already showed in previous talk, BlackHat 21, that these solutions are not effective and could be bypassed. In this talk, we will talk about the indirect MageCart that is done via third-party infrastructure. So in a regular MageCart attack, the client device is sending requests to load the application. The application is well secured, well protected, maybe behind firewall even, etc. Doesn't matter. It sends back an HTML page. The HTML page is rendered by the browser. And then the application is loading also other resources, some of them from third party. And for example, in this case, the application loads code from a third party. And if the third party is compromised, then the hacker can send malicious code to the application. The code runs in the context of the application, and the hacker can steal data from the application. Again, you can see nothing is visible on the server side of the application, on the organization's kind of network potential. So what we see when we analyze MageCart payloads. So first of all, we see that the most common use is to steal valuable data, whether credentials, private information, things that are typed in forms. And this is achieved by manipulating forms or by leveraging user access to read the data. So if the MageCart happens in pre-authentication pages, the hackers can steal what is typed by the users. In cases in which the MageCart, the hacker's code, runs after authentication, after the users are authenticated, the hackers can leverage the access of the users also to steal information that is not presented on the screen, but is accessible for the users. To avoid detection, hackers leverage public cloud infrastructure. And then if you analyze the traffic, you see data is sent to CloudFront, to S3, and it is more difficult to understand whether these cloud instances are the organizations, are legit third parties, or the hackers. In some cases, the payloads are not deterministic. They change or do not appear for every visit. This makes the detection more difficult. We are going to present two cases of MageCart, and the first one is going to be of a big vendor. So we talk about Microsoft, a trusted vendor. We are all using it. Microsoft, by the way, is a great vendor. And Microsoft has Windows application store, and it suggests publishing applications and kind of embedding, get it from Microsoft badges in your assets, in your website, so users can easily approach the store and get the app. And this kind of how to do this is referred from search engines, from the Microsoft documentation. And in the end, if you want to do that, you basically reach this page. And this page basically tells you, listen, type some details about your app, and we generate for you a code snippet. And this code snippet, as you can see, includes an instruction to load code from a Microsoft asset. So you embed a code snippet that loads code from a Microsoft asset. And at some point, we discover that this infrastructure that Microsoft tells everybody to load code from, well, it is critically misconfigured, and actually it went out of Microsoft's control. And basically, think about it. Microsoft is a great vendor. Many companies are loading code using this snippet. So it isn't about Microsoft being a great vendor. It is about one mistake that one out of tens of thousands of employees in Microsoft did at a specific point of time. And when you analyze Microsoft, you will never reach this one out of tens of millions, hundreds of millions maybe, of infrastructures that belong to Microsoft. So if you are an organization that was connected to this specific infrastructure, you didn't know about it, yet you were critically vulnerable to a MageCart threat through a Microsoft infrastructure. A second example, and again, from Microsoft, the giant, we will go after a case in which we talk about a small marketing company in Canada, small one, but used by Fortune 500 and other companies, mainly in the insurance sector. And a cloud misconfiguration that happened 3 weeks ago allowed hijacking of the content. By the way, this issue was fixed 2 days ago, fixed by the vendor, was active for 3 years, including in payment pages. Okay, so yes, it could be a giant vendor, it could be a small vendor, but anyway, it doesn't matter who the vendor is, because you need to analyze specific dependencies of infrastructures on external infrastructures. If you go after the vendor, you will never reach this sometimes esoteric infrastructure that in the end your organization is connected to. So Fortune 500 statistic for MageCart, on average, for the Fortune 500 company, there are more than 2,000 pairs of organizational asset and external assets, such that the organizational assets load code at least one time from the external asset. More than 23% are vulnerable to MageCart or were vulnerable recently. More than 3% are still, we have active abuse of them. And multiple Fortune 500 companies, as you could see, were the ones that were abused to conduct MageCart attacks against others, or are vulnerable and could be leveraged to run MageCart attacks against other companies. So MageCart summarized in the context of digital supply chain characteristics, attack once, hit many. Obvious. Yes, hackers find sometimes that these small vendors or forgotten infrastructure by big vendors are less protected and the attacks are stealthy. The most common, and the second example we bring, is asset hijacking. So we have organizational assets, and obviously, as an enterprise, we don't want to host everything in our networks, in our environment. For example, our marketing campaigns, in most of the cases, our main site will be hosted and operated by a third party. So it is very common to rely on external infrastructures. When hackers takes over the when hackers take over the external infrastructure, they can basically run malicious campaigns over organizational domains and serve malicious content, and even do it securely, because they can, in many cases, issue a valid certificate so they can run kind of secure assets of a brand and serve malicious content. When it is done in shared environments, then the hackers get their hit once, reach many. So first example of asset hijacking, hosting infra hijacking, is for phishing and scam. On the left side, we have a page of Microsoft. Okay. And this page includes a login page, but obviously that's a fake page. Somebody hijacked this subdomain of Microsoft.com and created a login page. On the right side, we have a case that reached the news about a Ferrari subdomain that was hijacked and abused by the hackers to sell NFT. The hackers basically leveraged the trust of the Ferrari domain, the Ferrari's brand, to earn money, trick users to pay. The most common type of abuse is black SEO and content spreading, malicious content spreading. There are two cases. In the first one, the hackers run their content in parallel to the hosted application. And in the second one, the hackers run the malicious content separately. So the misconfiguration prevents the original application from being active. The hackers just run their own content. And when they do so, they have the option to hide it or to just put their content. We will talk about a more interesting case. So hackers can upload innocent-looking pages like the ones you see, some generic error pages that you can see here and there over the web. And behind these pages, the hackers actually hide thousands of other pages, sometimes tens of thousands of them. And they basically link the malicious pages from these error pages or other benign-looking pages. And this allows them to trick search engines. By the way, they can also, in many cases, they go after the search engines and they leverage the control of the organizational assets to prove the search engines that they are the owners of them. But anyway, they succeed to manipulate also the search results. So the content is not only delivered via the hijacked assets and the domains that point at the hijacked infrastructures, but also via the search engine. So if you search for a brand of Fortune 500 company, you might reach a content that is served by the hackers. And when you follow the search results and you click on one of these search results, in many cases, you will be redirected to a page that dynamically analyzes where you are, and based on geolocation and other parameters, this page will redirect you to other pages with different malicious campaigns, etc. Another type of content that is spread by hackers, that's gambling content. We see porn, and we even saw a few cases of pedophile content. At the beginning of COVID, we had cases, including in companies that are kind of kids related. We found content that, well, is basically pedophile. And unfortunately, we have also such cases. One of the interesting things about hosting hijacking is the long abuse time. As you can see, some of these attacks are visible, okay? Yet it takes days to months to detect them. In many cases, we found multiple campaigns on the same asset. So we see an asset, it is hijacked by a Russian team, a few months later by East Asian team, etc. And basically, when we spoke with organizations that were affected, the reason for these cases, based on what they told us, was that they just didn't know about this asset. These domains are externally operated. Somebody else is running them on behalf of the organization. So it was difficult for them. They didn't track them. They didn't know about them. Obviously, they didn't track their digital supply chain. Some statistics show definitely that the most common, more than 70% of the Fortune 500 companies are or were vulnerable. More than 30% suffered and abused, some of them more than 10 times, at least one company more than 100 times. Talking about digital supply chain characteristics, so attack once hit many when happens in shared hosting environment. It seems that these attack paths are definitely less protected, at least in some cases, and the hackers can hide their attacks even when done like that. The third attack vector, what we call the most trendy, is mail hijacking. And we see an increase in indication of abuse of external mail servers, external mail services that are used by organizations. And by the way, we will show statistic. Organizations are using many more mail servers than what they think they are using. Over the years, they acquired subsidiaries. Each subsidiaries came with their own mail systems. Sometimes they were not decommissioned. For marketing campaigns, specific projects that require mail sending, new mail servers well defined that are not kind of the mail one. And talking about mail hijacking, controlling these external mail systems allow the hackers to send the emails from organizational domains or subdomains, and that's not by spoofing emails. The hackers can really send emails from the mail system, and they can also read the replies. So mail hijacking is difficult to detect because the abuse is not visible. When somebody leverages a mail system, which is external to the organization, to send an email, that's not something we could see from the outside easily or see at all. The abuse information that we have is something that we got, information that we got from organizations that we contacted and told them, listen, we believe that you might be under mail hijacking situation. And according to them, when the abuse was done, it was used for specific emails to specific people. So it was about targeted emails, so even more difficult to detect. The typical abuse is not like the one you see on the right, in which kind of mail system was hijacked and was abused to send mass kind of emails to people. So what can we detect from the outside? So first of all, we can detect the risk of being hijacked. We can detect that mail servers that the organization is relying on are critically vulnerable, critically misconfigured. We can detect changes that might indicate an abuse. So 2 examples, we can see a non-functioning mail server that we know is vulnerable becomes active again. We can see a new certificate that is issued for a vulnerable mail server, but the certificate doesn't match kind of the characteristics of the PKI the organization is usually consumes. So that's an example of mail hijacking case. And this is actually an example that is very interesting because it leverages a supply chain event, a SolarWinds. If you remember, after the SolarWinds event, you either sent emails to your vendors to understand whether they are affected, or you got emails as a vendor to understand whether your customers are affected. Okay, so we found that mail hijacking was leveraged, at least against one enterprise, to send emails to vendors of the attacked organization. And the hacker basically asked the organization, the vendors of the organization, to fill a questionnaire with details about the organizational, about the vendors, but also about the organizations itself. Okay, so we see kind of an opportunity that the hackers leverage with a really strong story and attacking kind of the vendors and not employees is actually a smart decision, because as a vendor, you don't want one of your largest customers to stop working with you. You usually do what they ask you to. An interesting point that we believe contributes to the recent increase is the fact that even organizational domains or subdomains that have no MX record can be attacked. Because according to the RFC, when domain or subdomain do not have an MX record, the IP address of them will be used as a mail server. So mail hijacking could be done also through load balancers and other services. So it makes the attack surface for mail hijacking, mail traffic routing hijacking larger and opens new opportunities for hackers. So some statistic on average for the Fortune 500 company, there are more than 188 different external mail services that organizational domains, subdomains are connected to. More than 40% are vulnerable to the direct and indirect attack vectors, and more than 18% are vulnerable to the direct variant in which a mail server is vulnerable. Abuse is difficult to detect. We spoke about it. It's very difficult to detect with high confidence. In terms of digital supply chain characteristics, attack once hit many, again, when it happens in a shared environment. That's the most stealthy attack, very, very difficult to detect. We also talked about this. The last attack vector is name server hijacking. That's what we call the most dangerous. DNS is the basis for every online interaction. When we use the web, when we send an email, when we connect a service, everything is done through DNS. The DNS resolution process itself, every time we want to know what is the mail server of a domain, when we want to know what is the IP of this domain, in each such a query, there are multiple name servers that are involved, including external ones. The external DNS servers that are part of this resolution process are amassed. Otherwise, you're not connected to the internet. Exploiting one DNS out of these many that potentially participate in the process allows the hackers to manipulate DNS records for organizational domains, to create new assets, to issue valid certificates, and basically control the assets. The most common variant of name server hijacking is done by attacking misconfiguration in between organizational domain and shared DNS infrastructure, whether in the cloud, Route 53, Azure DNS, but also regular DNS providers. Usually you share the DNS infrastructure with other vendors, with other customers of the same vendor. And if something is wrong in your configuration, you mismap the domain to the shared infrastructure, the shared hackers can manipulate the shared DNS infrastructure to attack your domain. Okay, so in this case, one misconfiguration affects one organization, potentially many assets of the organization. The less common variant is vulnerable name server, and we will bring an example for that. In this case, in a vendor's environment, when a name server that customers of the vendor are using, many organizations will be impacted. It is difficult to detect. DNS is designed to work even if some of the servers do not function. So somebody makes a terrible misconfiguration. One of the name servers is now critically vulnerable. It is no longer functioning, yet nobody notices because the DNS infrastructure keeps working. Sometimes it happens outside the organization. Remember that the whole process starts in the domain registrar. The domain registrar defines for the TLD name servers what should be used, and in many cases we have multiple zone delegations, many DNS servers that participate in the process. Sometimes the misconfiguration is between them. So exploitation of name servers is basically done by for asset hijacking. So just like second example we brought, abuse is visible, yet it is less common to see compared to the abuse that is done directly through the hosting providers. We can see mail hijacking. Hackers are no longer required to hijack the existing mail server. They can basically define new mail server for the organization. In some cases, it is possible to see that the hackers define for multiple organizations the same mail server infrastructure that is malicious. So that could be an indication just as well. And the hackers are also leveraging the control of the DNS to prove ownership to different services by adding DNS records, for example, TXT, to issue valid certificate. Name server hijacking example is a case of an insurance broker who runs web applications on behalf of insurance companies to sell policies, other services, and the management of these web applications website was done at the DNS level. Basically, the insurance companies defined the name server of their domain, subdomains, to be the broker's authoritative name server. And when there was a misconfiguration at the name server of the broker, basically all the insurance companies were affected and suffered an information leakage. Some statistics, so more than 7% of the Fortune 500 companies are vulnerable. We were able to detect abuse in almost 2% of them. And as of today, 3 companies do not control some of their name servers, and they are controlled by hackers. So name server hijacking summarized in terms of digital supply chain attack characteristics. Attack ones hit many, usually in the name server variant, not on shared DNS services. And the others are, again, could be relevant in some cases. We see that organizations fail to detect these cases. And well, as hackers abuse them, they are definitely less protected. Mitigation strategy. So we rely on the following observations. In many cases, the abused assets are previously unknown to the IT security teams. Organizations do not track their digital supply chain, the infrastructure, the asset they are connected to, but their vendors, they have ERP, they know their vendors, but they don't know the specific infrastructure. Some of the infrastructures are not in the vendor's list. Upon detection, the best thing, or sometimes the only thing they can do, is to disconnect, cut the connection to the abused digital supply chain infrastructure. Yet, it takes time to remediate. It takes time to find the relevant team who knows the vendor who can really go and cut the connection. And unfortunately, in many cases, organizations are abused after they detect the vulnerability because they do not react fast enough. The mitigation strategy we suggest is, first of all, inventory your assets and use an independent point of view to minimize the unknown. Zero trust. Do not trust yourself to know all of your assets. You can protect what you don't know. And obviously, if you don't know your assets, you can track their digital supply chain. So for each of the organizational assets, assuming that you minimize the unknown, discover and track also critical dependencies of them. Yes, sometimes non-organizational asset from which you load code is more important than one of the esoteric blogs of the organization. Monitor them just like you monitor other organizational assets with priorities and everything. Do it on an event-driven manner. For example, when new threats appear and on a day-to-day basis. For large enterprises, where the attack surface is large and complex, divide and conquer. It is almost impossible for a team to track the attack surface of an enterprise. for sure when the attack surface includes the exponentially larger area of digital supply chain. Let the different groups handle their own parts. Delegate the responsibility to other teams. Inspect and track their progress. That's not something you can solve immediately. That's a gradual process. Analyze the attack surface and start in the most vulnerable or most important areas, teams, entities in your organization. Obviously, these steps are things that we meet on our day-to-day with the IONIX platform. We help our customers to basically discover their assets, their digital supply chain, and also to manage them with this divide and conquer approach. So to summarize, hackers abuse external infrastructures to attack enterprises. Most attacks, data breaches, are not detected by the organizations. Most enterprises, governments, beyond the Fortune 500 statistics that we wrote, but yeah, better one we see, most of them are vulnerable. We talk about immediately exploitable issues. We detected active abuse in about 30% of the enterprises, organizations, again, beyond the Fortune ones. And remember that many exploitation use cases cannot be detected. Is your organization at risk or under active abuse? We are happy to help you find out. Thank you very much, and feel free to reach out with questions, with anything you want to me. Thank you.